Welcome and thank you so much for joining me today. So we are going to be looking at derivatives. In other words, we are looking at instantaneous rate of change. So let's go back over instantaneous rate of change, and we are going to come up with a formula for working that out. And that means will be coming up with a formula for our derivatives. So to start off, I'm just going to draw a graph. Nice and simple graph. Now, I'm going to do my graph and think about this here. This is my function is y, so my function is x squared. So that is half of my parabola. Now, the next thing that I'm thinking about is normally if we're looking at instantaneous rate of change or rate of change, we are looking at one point and we're trying to find another point close by to work out the change. The closer it gets, the more accurate it becomes to instantaneous rate. So that's what I know. I also know that it relates to rise over run. Starting to get there with our formula. So to start off, I'm going to say this is x. If that is x, change color. Trying to use as much color as possible so you can see. So if this is x, then the y will be the function of that x. Now this point here will be x plus this space, so x plus h, which means the y will be the function of x plus that distance. So I've got my points, now I'm going to put it into a formula. So just like what we did before, we did the function our y2, just like we have done before, our y2 for rise minus y1, which is our y. So function of x plus h minus function of x divided by our x2 minus x1. So we've got x plus h minus x. Now this changes the formula because x minus x is just nothing. So it leaves me with the function of x plus h, take the function of x divided by h. And this would be when I've got a limit of when h is 0, because we can't have h to 0, because we can't divide by 0. Okay, so this is our equation for the instantaneous rate of change. So let's have a look at using x squared and insert x squared into this formula. So if I have x squared, I'm going to then think, well, x plus h put into this formula, so I need I'll write it on the other side. So I'm going to write the formula as x plus h. Function of x plus h equals x plus h squared. And I've already got the function of x, which is x squared. So I've got the two things that I need. X squared, function of x is x squared. So all I need to do is substitute these into the equation now. Okay, so that just tells me that I have x plus h squared minus x squared over h. I am then, and remember that is the limit when h is of 0. Okay, let's keep on going. I'm going to expand these brackets out. So it's x plus h in brackets times x plus h in brackets. So that equals x squared plus xh plus h squared plus xh minus x squared divided by h. So straight away I can simplify this because I can see that I've got a couple of things that I'm able to see. The first thing that I see is I have x squared minus x squared. So they cancel out. The next thing that I see is that I have xh and xh. So I can add them together. So that will give me x squared minus x squared is nothing. Xh plus xh is 2xh plus h squared over h. I can cancel that h out in a minute because there's a common factor of h up the top. So h in brackets 2x plus h divided by h. H cancels out and it gives me a limit of when h is at 0, 2x plus h. So if when h is 0, our instantaneous rate of change is 2x. So rate of change is 2x. Really hope that helps you understand derivatives and instantaneous rate of change. If you need any more help, let me know and I'll get back to you.